Bismillah ar-Rahman ar-Rahim. Good afternoon, guys. Today I will try to illustrate the important information about Lecture 5, Part 2. At first, at Lecture 5, Part 1, we was talking about the electricity in the body. Specifically, we was talking about the nerve cell, what it inside it, uh, about the liquid, potassium, what was the charge kind inside this nerve cell. Actually, like we know, we have two different charge between inside and outside this any nerve cell, and any nerve cell has electric different potential across its membrane. It was equal minus 70 millivolt, and outside this nerve cell, the sodium ion, it has outside this nerve cell. Now, because now we believe we have electrical potential in each nerve cell, in each living cell in your body. Now let's imagine how we can benefit from this electrical potential by using oscilloscope to use this electrical potential to plot some diagram. At first, let me start from ECG. What this ECG? This device can measure, it's the content. The first one is the ECG. What is the ECG? Sorry, it's the electrocardiogram. That means something related with your heart. Electro from E, cardio from C, G from gram. At first, this electrocardiogram goal is to can examine the conditions of your heart. If your heart is normal, we can know that from this diagram. If something changed, something happened, we will know that from some digits, from some curves, some change in this curve. I will explain all of these, what that means, the small curve, the bigger one. After that, what is the two lines here? I mean, what is the x-axis? What is the y-axis? All of these information to can interpret this curve correctly. Here at first, like the previous lecture, we was talking about the nerve cell. I said when the nerve cell doesn't take any order yet, it was polarized. When start to take any order, that means will change to be depolarized. It's important. The same thing with your hair cells. Here, polarized and depolarized hair cell can be detected at the surface of the body. The signals are much attenuated, that's mean weak, by their passage. Because this problem, we will use amplification process to decrease this wave, this sound, this hertz, to make the charge recorder or oscilloscope to make it can take this change and convert it to be to plot some change in the diagram. The display is called an electrocardiogram, like I said before, and it can provide useful information about your heart conditions. Here, we will attribute what all of these simple stickers. Actually, all of these are electrical electrodes. All of these try to take the electrical potential, the sounds, the vibration from your heart muscle and decrease it by amplification process to send appropriate signals to this ECG device to can plot this diagram. Now let's take a look to this curve. If I take any athlete man, don't suffering from any problem in its or her heart, that I will take curve plot like that. Actually, at first, let's discuss what is the x-axis and y-axis. X-axis here is time and its unit is second. At y-axis, potential at body surface, its unit is millivolt. Here from 0 to 1, I have P, Q, R, S, and T. We'll discuss all of these three curves, and we have two intervals. Don't forget it. PR interval, QT interval. When some change will happen on one of them, what that's mean? Actually, before going to interpret all of these, let me say some important information about your heart. In your heart, you have two atria and two ventricles. That's important because, for example, QRS indicates some change in your ventricle. PRT indicates important information about your atria. Let's discuss all of these here from this curve. Let me take the bigger one, QRS. When QRS decreased in your heart curve, what that's mean? That's mean you are suffering from reduced ventricular contraction. Some problem in your ventricle muscles by push the blood like must be, okay, and ventricles. After that, let's go to this curve, to T. When T curve decreased or increased, what will happen? When decreased, heart muscles, that mean lacks oxygen. Some missing oxygen, it's happened. When increased T, what that's mean? That's mean we have excess potassium in your body. Let me come back to this important word, potassium. Like I explained in the previous lecture, we say in your nerve cell, potassium is inside, sodium ion. Don't forget it. Potassium ion is outside. When at specific condition, the membrane will be attunable. Some potassium will penetrate this membrane to be outside. That's mean potassium outside your nerve cell will increase when this nerve cell be ready to take any order. Here, when T is increased, that's mean a lot of this potassium in your body. Increased. Now let's come back to complete with these two intervals, QT and PR. At QT, when this interval is increased, here it started from less than 0.4 second to less than 0.8 second. When this interval increased, what that mean? That means you have heart attack. It's dangerous. Heart attack. But in babies, when suffering from some problem in their hearts, and they are stay just kids, that's mean approximately when we do this process to them, we will note increase in PR interval. Like we know, like we are saying here, PR interval is starting from less than 0.2, less than 0.4 second. When increase in PR at the curve, that means this kid suffering from scarring of atria. Now let's come back to interpret what this P curve means. At first, let me take some pictures to prove my words. Here, it's a normal ECG to any athlete, man, woman, okay? When long QT curve, what that's mean? That's mean increase QT interval. That's mean here, this patient suffering from heart attack. When QT increase, that's mean heart attack. When PR interval increased, that means scarring of atria, like I said before. Here, this PR, here is non-normal thing it's happened. QT is less than 0.4, less than 0.8. Here it's more than. That's mean I'm talking about QT here, and PR interval must be less than. That's mean here your patient suffering from scarring of atria. Here now let's come back to P wave. What does mean? That's mean depolarization. That's mean this heart cell started to take the order, started to do its job. Here, P wave related with atria, not with ventricle. Be careful from that. The P wave, that's mean depolarization and contraction of the atria, started to push blood. The QRS, the bigger curve wave, that's mean depolarization and contraction of what? Of ventricle. Like it's clear here, ventricle muscles, it's bigger than atria muscles, okay? The last one is the T wave, that's mean repolarization. This heart cell started to come back to its origin situation. And relaxation of what? Of the ventricle. Here now we interpreted the PQRST curves. And we didn't forget the PR interval and Q and the another interval, it was the PR, and the other it was QT. Actually, all of this information is important. I take many questions from them because that my advice is to be careful on this lecture. Yes, here, this, if you remember that, this picture illustrates to us someone use the CRO, is using the CRO to display waveform. Which waveform? It's ECG to some patients. Here it's clear, P curve, QRS, and the last curve it was T, and QT interval on the another. From here and here, all of these at T, it's done, it's finished. That's at less than 0.8 seconds. That's mean here your patient is normal. By this picture, I did a good link with a previous lecture when I was talking about CRO, and I said it has many uses, or let me say many usings. One of them, it was voltmeter. The second using was we can use it to display waveform. When ECG curves, it's a waveform, we can use it by produce recorder, paper recorder, or I can use the electronic screen like CRO. That's mean here, CRO, it's important part, the research, the physicist, the specialist use it as a screen in ECG. Here we have another machine. It's electroencephalogram, EEG. Like we did to examine your health conditions, we can use the same idea to examine your mind health. The same situation with your heart in your chest. In your chest, you had different potential in your chest service. The same situation in your head. Okay, let me go deeply with this information. The action potentials of nerve cells in the brain give rise to electrical signals that can be detected at the surface of the skull brain waves. Here, the action potential in your skull will give some change in electrical signals to made electrical beam. This electrical beam will act by somehow on the electronic screen. By that, we can plot some curves. This curve has some meaning. And sure, we have different hertz in your mind, in your sleep. The situation is different. When you use your mind to solve some mental activity, or when you be in a dangerous, some animal behind you or something like that, I don't know, but some critical situation, when you will be in a critical situation, sure, your mind will emit different hertzes, different from when you are sleeping, different when you are in relaxation, or when you are watching TV or another situation. My goal is to prove you have different situation with different hertzes emitting from your mind. And I will explain that, I will prove that by depending on the scale. They can be mounted by placing electrodes on the skull. All of these blue things on its head, head, all of these are electrodes. Try to take the electrical potential on her skull, and by application process, because this different potential here on her skull, it's small, simple amount, approximately 50 micro, not milli, microvolt. By that, by amplification process, this electrical electrodes will try to increase them and send this to the EEG device. By that, the waveform is not repetitive. By that, we can plot curve like one of these. Here, let's take some notes by compressive with the ECG device. Here, the waveform is not repetitive like that produced by the heart, and accepts many variation in both frequency and amplitude. Here, it's easy to note the curve at data is different from beta. Here, these lines is, how I can explain that? Some clear difference between delta and beta. That's according to the hertzes amount. Okay. Here, let's explain all of these at beta. It's the maximum hertzes your mind reach. Beta waves from 14 to 100 hertz. You can reach this a huge amount when you is in the critical situation like mental activity. Alpha, actually, it's less than from 8 to 13. All the alpha, all the yoga players try to reach this amount by closing their eyes and totally relaxation, try to reach this goal, try to reach this huge amount of hertzes that decrease your activity minds. It's make your mind be better from many skills, because that the yoga is very benefit. Here the third one is theta is less than alpha from 4 to 7 hertzes. It's be to children and to any adult suffering from emotional stress. The last one is delta. It's from zero point 0.5 from half to 3.5 hertz. It's during sleep. That's mean when you are asleep. This hertz starts from zero point 0.5. When you reach deeper sleeping, you will reach 3.5 hertz. This from this number to 3.5 hertz. Here, okay, now you test this device on one from your friends. Sure, your friends didn't suffering from any mental disorder, okay, from any brain disorders. Now, how we can benefit from it? And we proved you have 4 different hertzes in 4 different situations, from sleep to mental activity. Now, how we can benefit from it? We can benefit from it when we use it on some persons suffering from brain disorder. For example, we can diagnose the epileptic disease to any patient by using EEG device. Here it's clear here when the epileptic situation is coming, your patient brain hertzes is increased to be like it's clear, it's more than 100 hertzes, and it's very painful. Another using to EEG is in research on the nature sleep, and last one to monitor the effect of anesthesia during surgery. Anesthesia, it's a great department and very important department in your patient's life. That's it. Thank you about your watching or listening. Have a good day and see you in the next lecture. Bismillah.